Welcome to Engineering Out Loud, the third episode in our series from MECHESOL's MESP Management Development Program, titled Six Sigma Methodologies.
Okay.
Today we're going to dive into Six Sigma Methodologies for Process Improvement. And to really grasp this, we'll first break down what a process actually means within the Six Sigma framework. Then we'll explore two key methodologies, DMAIC and DFSS. If you're ready to boost your process, know how to apply what you learned today, or register for the full MESP Management Development Program, visit mechesolco.com/CPD.
Does sound good.
All right, let's get started. So when we talk about process in Six Sigma, what exactly are we referring to?
So basically, a process is any series of actions or steps that you take to achieve a particular end. It's how you get from point A to point B to reach a specific result. And it doesn't have to be just about those huge manufacturing lines. It can be anything like how you handle customer emails, how you design a new product, or even how you run a team meeting.
Okay, so it's a pretty broad concept then.
Okay. Exactly. And to really understand a process in Six Sigma, we often use a model called input process function output. It just helps us break down what's happening in simpler terms.
All right, I see the letters there. So let's start with inputs, the X in the model. What are those exactly?
Yeah, the inputs are basically everything you need at the beginning of the process to get it started. All the stuff you need to make it work. And these are often referred to as the X's because they're the factors that can cause changes in the final outcome. Think of it like the classic 4 M's materials, machines, manpower, and methods.
Okay.
Those are your key ingredients that go into the process. So materials are like the raw materials, machines are the equipment, manpower is the people involved, and methods are the procedures or the steps that you're following.
Got it. So we have the raw materials, the tools, the people doing the work, and the instructions or processes they're following. Those are our X's. Now, what happens to these inputs in this process function, the FX part?
That's where the magic happens.
Yeah.
This is the transformation stage where you take those inputs and actually do something with them.
Okay.
It's where the value is added or where the inputs are converted into the desired outcome. Like think about baking a cake. The process function would be all the steps like mixing, baking, turns the flour, eggs, and sugar into that delicious cake.
Okay, so the process function is the transformation itself. And then we come to the outputs, the Y. That seems pretty straightforward. It's what we get at the end, right?
Exactly. The outputs, or the Y, are basically the end results of your process. They're the products, the services, anything that's delivered to your customer. And remember, customer can be external or even internal within your own organization. It's the effect of all those inputs and the process working together.
So we put in the ingredients, our X's. We bake it according to the recipe. That's the FX. And we get a delicious cake. That's our Y. Makes sense. But you also mentioned something called a feedback loop earlier. Why is that so crucial?
Yeah, the feedback loop is essential because it makes the process dynamic. It allows you to constantly learn and improve over time. Basically, you measure your output, your Y, and then you use that information to adjust either the inputs, your X's, or even the process function itself, the FX. So let's say our cake keeps coming out dry, right? The feedback loop is realizing, hey, the cake is dry, and then adjusting maybe the recipe, which is the method. Or maybe checking the oven temperature, which relates to the machines for the next time we bake. It helps you ensure that your process is truly effective and keeps getting better.
That visual representation really helps to clarify things. ANPTX leading to process FX, resulting in OutPTUY with that arrow looping back from output to input. It really drives the point home.
Okay, so we've got a good understanding of what a process is in Six Sigma now. So let's move on to the methodologies, DMAIC and DFSS. What's the main difference between these two? Okay, so think of it this way. DMAIC is like a doctor who's treating a patient who already has a health issue. They're trying to improve an existing process. That's not working the way it should be. On the other hand, DFSS, or Design for Six Sigma, is more like an architect. They're designing a building from scratch, making sure it's strong, and meets all the requirements from the very beginning. It's used when you're creating something entirely new or completely overhauling an old process. You're aiming to build in that quality and reliability right from the start.
So DMAIC is for fixing something that's broken, and DFSS is for building it right the first time.
Precisely.
I like that analogy. Let's dive a bit deeper into DMAIA. What does that acronym stand for, and what are the steps involved?
Okay, DMAIC stands for Define, Measure, Analyze, Improve, and Control. It's a data-driven quality strategy for improving existing processes. It's a very structured approach, and it acts like a roadmap to guide teams through problem-solving and quality improvement.
Okay, define. What happens in that initial phase?
So in the define phase, it's all about getting very clear about the problem you're trying to solve. You're defining the problem itself, setting very clear project goals, and figuring out what your customer really needs and expects. And a big part of this is identifying those critical to quality aspects, the CTQs. These are the things that are most important to the customer. You're essentially figuring out what matters most. You also create a project charter, which is like a mission statement for your project. It outlines the scope, the objectives, and the deliverables. It's like the guiding document for the whole project. Then you form your team, you assign roles, and make sure everyone understands who the stakeholders are and how they're involved. Now, interestingly, to even begin the stiffling phase, you need a few things. First, you need to recognize that there's a need for a Six Sigma project in the first place. You need that buy-in from leadership, and you need to have your core team ready to go. Tools like organizational charts and high-level process maps can be really helpful in this stage. So what do you get out of this phase? Well, you get that project charter, a clear set of metrics that you'll use to measure your success, a concise problem statement, and a good understanding of everyone's roles and responsibilities. Oh, and one crucial thing. Those goals you set, they need to be SMART. That means specific, measurable, achievable, relevant, and time-bound.
So setting a solid foundation is really key here. Then what comes next?
Then we move on to the measure phase. This is where you actually start collecting data on how the current process is performing. You're establishing a baseline. So basically, you're figuring out where you're starting from. And you also need to make sure that the way you're measuring things is accurate and reliable, that your measurement system is valid. So you're assessing the current situation, you're gathering all the data, and using descriptive statistics to really understand what's happening. It's like taking a snapshot of the process before you make any changes. Now, the input for this phase comes directly from the define phase. You have your project charter, your roles and responsibilities, and that problem statement. And some of the tools you might use include data collection tools, more detailed process maps than you used in the define phase, and descriptive statistics to summarize all those findings. The key takeaways from this stage are well-defined processes, having that baseline data and those established metrics that you'll be tracking throughout the project. And this phase is really important because it acts as a bridge between defining the problem and moving on to actually analyzing it.
Okay, so we know what the problem is and we've measured how things are currently working. Now we go into analyze. What's the main objective in this phase?
This is where we put on our detective hats. In the analyze phase, you take all that data you collected in the measure phase, and you dig deep to figure out the root causes of the problems. You're trying to identify those critical factors that are causing the majority of the issues. It's all about finding the real reasons behind those defects or inefficiencies, not just the surface level symptoms. The inputs for this phase are the baseline data, the process maps, and any initial list of problems that you might have. And common tools include cause and effect diagrams, sometimes called fishbone diagrams, techniques like the 5 whys, which helps you drill down to the root cause, and statistical analysis software to look for patterns and relationships in the data. What you're looking for might not be obvious at first glance. So the main outputs of this phase are those identified root causes, which are the things you really need to focus on addressing, a much clearer understanding of how the process actually works, and some initial ideas for improvement. This phase ensures that your improvement efforts are targeted effectively.
Okay, we've identified those root causes, so now we can start fixing things in the improve phase, right?
Absolutely. The improve phase is where you put your solutions into action and really see if they're working. This often involves brainstorming and selecting the best ways to optimize the process, reduce waste, and eliminate those root causes you identified. You implement these solutions and monitor their impact to ensure they're delivering the expected results. And statistical validation is super important here. It helps confirm that those improvements are measurable and truly making a difference. You're trying to make the process more capable of consistently meeting those quality standards. And you also need to consider the cost effectiveness of your solutions to ensure they make good business sense. So the inputs for this phase include those identified root causes, an understanding of the performance gaps you need to close, and a cost-benefit analysis of your proposed solutions. Tools you might use are a solutions design matrix to compare different options, design-it experiments, or DOE, to see how different factors interact, and Taguchi methods for designing really robust processes. What you get out of this are a good understanding of how capable those proposed solutions are, the selection of the specific solutions you're going to implement, and a detailed plan for how you're going to put them into action. This phase really sets you up for that final control phase.
Okay, we've made the improvements. How do we ensure those improvements stick around in the control phase?
The control phase is all about making sure those improvements last. It's about putting systems in place to monitor the improved process and prevent things from going back to the old ways. You're revalidating your measurement systems to ensure they're still accurate. You're verifying that those process improvements are having the impact you expected, and you're developing control mechanisms. These can include standard operating procedures and training programs to maintain those improvements. You also want to keep an eye on those critical process variables, the X's, to ensure they stay within those acceptable limits. So tools that are commonly used in this phase are control charts, which help you track process performance over time visually, and other statistical process control or SPC methods, as well as detailed documentation of that improved process. The main outputs of this phase are a process that's consistently performing at that improved level. Well-documented improvements that you can refer to in the future or use for training purposes, and a feedback mechanism to continuously monitor performance and catch any new potential issues early on.
That's a really thorough breakdown of DMAA. It sounds like a very systematic and effective way to tackle those process problems. Now let's switch gears and talk about DFSS design for Six Sigma. How does it differ in its approach and goals?
DFSS takes a more proactive approach. Instead of fixing an existing process, it's used when you're designing a new process, product, or service. Or if you're completely redesigning an old one, the goal is to achieve those Six Sigma quality levels right from the start. So the focus is on innovation, and building in quality and reliability is a core part of the design process. Some common DFSS methodologies include DMADV, which stands for Define, Measure, Analyze, Design, and Verify, and IDOV, which stands for Identify, Design, Optimize, and Validate. Key characteristics of DFSS are a strong customer focus, understanding their needs from the very beginning, designing for quality by incorporating practices that help prevent defects early on, and optimization using advanced techniques to create the most efficient and effective design.
So it sounds like DMAIC is like fixing a leaky faucet, while DFSS is like designing a plumbing system that's guaranteed not to leak in the first place.
That's a great analogy. DMAIC is reactive, addressing problems in existing processes, while DFSS is proactive, aiming to prevent problems by designing things right from the start.
This has been incredibly insightful. We've covered the fundamental concept of a process in Six Sigma. We broke down the DMAIC methodology step by step, and we understood the core principles of DFSS. Ready to take a deeper dive and learn how to apply these methodologies in real-world scenarios? Register for MECHESOL's MESP Management Development Program at mechesolco.com/CPD.
Absolutely. And it's fascinating how both DMAIC and DFSS, though used in different situations, are both driven by data and a commitment to quality and customer satisfaction.
Exactly. So just to recap, we learned that a process in Six Sigma is a series of actions transforming inputs into outputs, guided by a crucial feedback loop for continuous improvement. Then we explored DMAIC, the structured 5-phase approach for improving those existing processes. And finally, we looked at DFSS, which focuses on designing new high-quality processes and products right from the get-go.
And if you think about the bigger picture, understanding these methodologies gives you powerful tools not just for fixing immediate problems, but for building more effective and reliable systems from the ground up, leading to better outcomes for your organization and your customers.
Now think about a process in your own work, or even in your personal lives. How could understanding the inputs, the process itself, and the outputs, or applying the structured thinking of DMAIC or the design focus of DFSS help you achieve better results? It's something worth considering. To further explore Six Sigma methodologies and apply these powerful tools to enhance your engineering expertise, visit mechesolco.com/CPD. Apply today.